All right, hi guys. We are gonna get started so I can keep everyone on track, because if you know anything about me is I like to be on time. But realistically, it's not that realistic. So welcome to the TGCT Day of Learning in Columbus, Ohio. Super excited. Most of us here are not actually from Ohio. We have someone from South Korea, Mississippi. Anyone else from a different state? I know DC area, Kentucky, Indiana. We have 2 Indianas, Minnesota, Boston, yeah.
North Carolina.
Washington, North Carolina. Yeah, so as you see, many of us will go anywhere to meet each other. So it just shows how impactful it is. And I just wanted to thank you deeply and truly for coming out and supporting each other and supporting TGCT Support, because we literally need you. So let's see. So we have a jam-packed day. This is my welcome. So we are at the welcome session. And I will go into my TGCT 101, where you'll hear background and a crash course of how molecular biology of TGCT works. We'll go into the art of oncology, starting with imatinib and Tralio, and probably nilotinib with Dr. Burgess, as well as treatments for clinical trials with Dr. Tinoco. And then we'll end it with preoperative treatment and surgical management of TGCT with Dr. Scharschmidt. We'll do a roundtable discussion, as well as a break for lunch, where you can mix mingle for 30 minutes, use the bathroom, anything you need. And then we'll have a patient support group. There are a few pharmaceutical companies. During that group, we will ask them not to participate and maybe to step into the other room to allow patients the ability to speak freely and openly as they would like to. And then lastly, I will close, and it will be very sad, but we will have another one of these and you can come back. So I wanted to start with an introduction of the doctors. They are donating their time here. They feel just as invested in the community as each and every one of us. So it's very important we thank them for being here, as well as introduce them. So this is Dr. Melissa Burgess, and she'll wave to you all. You'll hear her later. She's an assistant professor at the University of Pittsburgh School of Medicine and a medical oncologist, a very elite one at that. She specializes in treatment of soft tissue and bone sarcoma and Merkel cell carcinoma, which was made famous by the guy who just died, right? Who's
Jimmy Buffett.
Thank you. See, I'm clearly too young to know who that is, it feels like. Jimmy Buffett then.
No, actually,
And so Dr. Burgess is a board certified internal med and med oncologist, or medicine and medicine oncologist. She received her medical degree from Drexel in Philadelphia, and she completed her residency in internal medicine and her hematology and oncology fellowship at UPMC, where she is now. She is a member of many societies, including the American Society of Clinical Oncology, Connective Tissue, Oncology Society, CTOS, which is actually like next month, in Ireland, and the American Association of Cancer Research. And she's interested in novel therapies for soft tissue and bone sarcoma, with a special interest in immunotherapies, which are not yet used in TGCT, but widely used in sarcoma. Dr. Tinoco is a medical oncologist. Wave to the people, Dr. Tinoco. Cool. He's a medical oncologist who specializes in treating patients diagnosed with bone and soft tissue sarcoma. You'll see a trend. Everyone's in sarcoma. He received his medical degree from, I am going to butcher that, I am so sorry, Universidad Nacional de Colombia in Bogota. Shoo. That is 8th grade Spanish, people. The Educational Commission of Foreign Medicine medical graduates in Philly, and then he completed an internship and residency at Harbor Hospital in Baltimore, so fellow Baltimore person, and a fellowship at University of Miami. He is part of a multidisciplinary team comprised of medical oncologists, surgical oncologists, orthopedic surgeons, radiation oncologists, and pretty much anyone under the sun here at the James. Though through the treatment of sarcoma, he's acknowledged how difficult it is, and that the sarcoma team combines cutting-edge technology in clinical trials to deliver unparalleled quality care. And we know that because some of his patients are here. So very elite. He has most of the clinical trials at some point for the disease. And his recent project looks into tumor DNA as a diagnostic tool for sarcoma. He also just had a baby. So he is here on zero sleep. And lastly, Dr. Scharschmidt. He is the director of pediatric orthopedic oncology at Nationwide Children's Hospital, and he works as a professor in orthopedics here at the James as well. He received his medical degree from Northeastern Ohio University and completed his residency at Summa Health System. He completed his fellowship in musculoskeletal oncology at University of Washington, go Huskies, and Seattle Children's Hospital. He has an interest in bone and soft tissue sarcoma in children and adults, both benign and soft tissue tumors, as well as a complex limb reconstruction, advanced reconstruction options in growing children, as well as the care and oncology of patients with amputees and spine tumors. He's very distinguished, published quite a bit, and received many awards, including Educator of the Year in Orthopedics, as well as Medical Student Teacher of the Year, which is why he's such a good speaker. And so if you've ever heard him speak, you know that firsthand. And he gave one of our webinars for AMB 05X at one point as well. So that's my spiel, as well as the introductions to these lovely doctors. I am Sydney. If you've not met me before, I have a PhD in pharmaceutical sciences, and I work in oncology as well. What I'm really here for is I also am the director of TGCT Support, which is the only nonprofit program for TGCT. It's under a program called the Life Raft Group. And so I think it's really important many people hear the origin story, because a lot of people, Sydney came to be and it was like a pop in the night. It just happened overnight, right? But for us, it really didn't feel like it. And so there is a story that goes with it. And so the Life Raft Group, Sarah Rothschild's to be specific, who many of you have seen before or known in some capacity, they went into one of the TGCT Facebook groups, and she asked a question: would you change your diet for a drug to be more effective? It was really a simple question she asked to a bunch of patients out of interest in what we're willing to do for treatment. But of course, nothing is simple when I'm here. So I answered some long, very technical about, well, food, it depends the content of the food, the composition, how much fat is in it, and may affect absorption. That's dictated by labeling. And she was like, who is this person? Why would you answer like that? So she messaged me personally and had said, like, I need to know more. Who are you? We have an interest in this disease group, but we really don't understand it. And so we met online, and it was love at first sight. They have, and many of you know that I don't half-ass anything. I like full-ass it. So I met her, and I just dove fully into the experience of TGCT. And I've been a patient since I was 17. So it seemed right at home for me to continue on the journey with all of you guys. And so that started our endeavor with the first webinar, which was Giant Cell Tumor 101. It included giant cell tumor of the bone and TGCT. And as you saw, we posted on both before TGCT Support even really existed. So we posted it on both about 2 years ago, and it has over 1,000 views. So, right, we exist. There's people out there. And some of you are even here. And so that caused the inception of TGCT Support, started in 2019 with that webinar. And here we are today. We have over 1,000 patients involved. And so I have a little stat. So we started in December 2019, so it doesn't really count. It was 2020. Middle of COVID, so I had plenty of free time suddenly. And so that really built it up. We have a total membership of 521 patients. That just includes that participate individually within the organization. We have 6 different support groups in English, French, and German, including all over the world, including Australia, Germany, France, the US, and Canada. We have a wide distribution of patients. 86% of our patients are patients, and 14% are caregivers. For TGCT, and we also have, I couldn't leave my GCT, my giant cell tumor of the bone people behind. They are a rarer form of a disease within a similar family. They are essentially a bone tumor that resembles a lot of the same treatment options with surgery as we do. And at times they're like TGCT 30 years ago. They have no real new options. And so I couldn't leave them behind. And so we have these neighboring, most people don't know that I also do GCT on the side. And so that also exists for those pharma people in the back who'd like to drug develop in that area. And so 98% of that population is patients, as well as 2% caregivers. We have many, many, many group members who have attended. So 391 TGCT members have attended a virtual support group, most of you repeatedly, as well as 166 mentor pairs. So if I've ever asked you, would you like to mentor a patient? You're one of these people. And there's many of you. And so we have 106 volunteers, as well as 99 people who have helped with fundraising. So all of this could not be possible without everybody here. And we have 2 registries. That's my prized pig right there, is the registry. And we have over 600 to 700 patients within that registry, all unique patients, all diffuse patients who answer repeatedly over time. So we can get data. We can answer our own questions with a little bit of help from all of these validated methods that we have access to, but most people don't know how to use them, right? I'm a scientist, that's what I do. So we together can really answer a lot of the questions that we need, and make all of our lives easier, right? When insurance goes, we don't want to approve that. We have data now to say, well, actually, this benefits this many people. So it can help in many different facets. And so I have a scan me for anyone that hasn't done the registry. There's a shout out to please help, please do it. And at any time you can ask me for your data and I will plot it and make it look pretty so you can see over time how you're doing. We have 22 countries involved, with the US, UK, Australia, Canada, and Germany being the top. But as you see, we have people from South Korea as well as China. And pretty much if there's a TGCT patient, they've probably heard of us ideally by now. If not, I am coming. So I want to say thank you to the Life Raft group particularly. They have been a mentor. They have allowed me the connections with these amazing doctors as well and given me the platform you guys all see. So they work primarily behind the scenes, but they do a big job. The fundraising committee that helps me decide how to spend money, essentially. Investigators who are willing to do research in a space that's very small, right? If you think of funds, it's not going to be allocated to rare diseases as often. So these people are truly have a dedication beyond just monetary. Physicians who are also often principal investigators for that, our medical advisory boards that helps me answer questions that they have in our community, and sponsors and donors that allow TGCT support to run. It is a donation-based organization. I am not paid. I am entirely volunteer. So everything is based off of donations. To have things like this, it's donations. So it's extremely important. There's my shout out for donations. Patients, most of all, right? That's why we're here. If we didn't have a disease, we wouldn't be here. So have to thank all of us for bearing the burden of the disease, as well as we have several pharmaceutical companies, particularly Abisco, DSI or Daiichi Sankyo, and Decipher, who have supported this specific event, as well as many of our educational programs, right? Everything takes money. And so they really help us deliver the message, and they're aligned with that as well, in I'd say most cases. So if you're not done hearing from me, you're going to hear now another brief 30-minute session of the biology of the disease. And so, as I said, I am a scientist. I am not a physician. So I work specifically in cancer research. I do not work directly treating patients. Nothing in this presentation should be regarded as medical advice or as a substitute for consulting qualified providers. And if you need one, you know where to find me. I will set you up with one. So we will go through what is TGCT, the history of that name change. Many of us will call it PVNS. Some people call it TGCT. Where did that come from? What is TGCT actually? What is it made up of? What's the cause? What is CSF1? And a crash course in molecular biology, because I have to. I can't not talk about biology, right? And then how do we target CSF1? And I will hand it over to Dr. Burgess to talk about the actual drugs that do that. So what is TGCT, or tenosynovial giant cell tumor? It's a benign neoplasm of unknown origin that occurs in the synovium, the tendon sheath, or the bursa. If we talk about what each of these are, the synovium is this capsule area that acts as a fluid-filled sac for your joint. And so that outside, I think it's, do I have a pointer? Cool. So it's this area of the actual joint. It houses everything. And then you have, sorry, it's a slight lag. The tendon sheath, which is that area that cushions the outside of these flexors. And then you have the bursa, which are these fat pad sacs that act as a cushion or a gliding surface to reduce friction. And so all of these tissues have one thing in common. They are soft connective tissue. They all come from the same lineage, right? There's no such thing as a good tumor or a bad tumor. So I hate the word benign, right? Tumors are all kind of bad. Some are really bad and some are less really bad, but all of them are bad, right? Some are not aggressive, some are potentially life-threatening. And so if we put them on this scale of good to bad, that's very binary. So we like to keep it on the spectrum of what bad could be, essentially. And so both affect your quality of life. That's the most important. When I was diagnosed, I was told it was akin to a liver polyp. None of us would say it's like a liver polyp, right? It's super impactful. And so that was a way to dismiss the feelings that I was experiencing. And that, so just to talk about what's good and bad, those words do not exist when you talk about tumors or biology in general. It's never that simple. And so when we start to separate TGCT from cancer, you see very distinct differences, right? TGCT is not cancerous. And so it's not always going to be fast growing. And when you look at the actual spectrum of growth, it's on the lower end. Even the most aggressive TGCT patient may be more like a low-grade cancer. It still doesn't always mimic the same way cancer would, but it's a spectrum. It's locally aggressive, meaning it's monoarticular, which is a fancy word for it affects a single joint. It rarely metastasizes. I often hear patients say, well, what if it spreads? Do I need a full body MRI? Like, it doesn't spread. Like, one worry we don't have to worry about is it doesn't spread. We're okay. That doesn't mean that if you have pain elsewhere, it may not be indirectly related to like compensation or any other symptoms you're experiencing. You just don't have to worry about spread. Largely, this disease puts stress on bone and tissue and joints, and that's why many of us experience different intermittent sessions of what we call like a flare. Cancer is systemically aggressive. It often, particularly sarcomas, can spread. It's life-threatening, and it can dissolve and invade healthy tissue. So these are a spectrum of different sides of a coin, right? And so they share components where they could be fast growing. They could have no distinct borders. So tumors that are cancerous are really hard to sometimes take out because they get everywhere. TGCT can be really hard to remove because it gets everywhere. So they share components, as well as they can be treated with targeted chemos. Any drug that kills a cell is called a chemotherapy. That is just inherently the class of the drug. When it targets something, it's not what we think of like your hair falling out and the battery acid bag that hangs behind you. It's targeted to a specific source, and we'll talk about the source. But both diseases, both cancers, particularly sarcomas, and TGCT can be treated within this drug class. So this name change, pigmented villonodular synovitis, or PVNS, was its formal name. In 2013, TGCT was divided into two subtypes to encompass PVNS, nodular synovitis, giant cell tumor of the tenon sheath, and tenosynovitis, as well as many other random names you hear throughout the groups. So they took all of these names, they put it under a single entity where you see PVNS, nodular synovitis, get in there, all of you. We make one entity together known as TGCT with two distinct subtypes, the localized form, sometimes called the nodular form, depending on where you live, or if you're a pathologist, and then the diffuse form. So we separate these by some of the features. Diffuse form typically affects larger joints, particularly the knee, which you'll see some stats on. It does not have distinct boundaries. This is what makes it difficult to remove. You can't tell what's healthy, what's not healthy, and Dr. Scharschmidt has some great pictures and images of how difficult it can be to remove. It's typically larger tumors, and we're going to get rid of that definition because it's not actually true. How big a tumor is, how small it is relative to so many factors like the joint size, who you are, your symptoms. So there's no size that suddenly means it's big. There's no size that suddenly means it's small, and there's no size that suddenly means it's diffuse versus localized. What we do know is the diffuse form typically encompasses part or all of the joint. And so nodular form is typically a single tumor, and it's well encapsulated, which means it has a complete boundary around it. It's like a little knapsack where you like yank it out. And as long as you don't cut through it and spread the tissue around, you may be able to remove it, and surgery is often curative. Because of that, whether the boundaries or no boundaries, diffuse disease is more aggressive. It is harder to remove inherently. Localized is less aggressive because like that tumor little knapsack, you can rip it out. And as long as you rip it out properly without cutting through it, the recurrence rate is quite low. It's around 15%. Whereas for diffuse disease, it's high. It can be anywhere from 50 to 70. And for those with repeat surgeries after recurrence, it can go as high as 88% even. But as many of us here, probably almost all of us have some form of diffuse disease, right? That's pretty common amongst the groups. They're the people that suffer the most. But largely, TGCT is made up of localized disease. So I always hear primarily orthopedic surgeons go, or sports medicine doctors, and go, well, I see all these all the time. What they mean is they see localized tumors occasionally that may be misdiagnosed for this disease. Or they do see this disease, but they're primarily not seeing the full form of the diffuse disease because they don't come back. Patients don't come back, they get better, they move on. But primarily this disease is made up of localized. And the nodular or the localized form is 39 per million, and we'll talk about what that means. And the diffuse form is 4 per million. So we make up 43 per million people. And so when we talk about like these random numbers, people, I all the time hear someone say, oh, my doctor told me I'm 1 in a million. Like 1 in a million what? Like in what time frame? And so all of these have meaning, right? There's science with everything, right? And so incidence is the measure of the new cases in a specific time period. So for we'll say a time period of a lifetime, the estimate is around 41 to 45 people per million will develop the nodular or localized form of the disease. Whereas 5 to 8, 5 to 9 people per million will develop the diffuse form, right? So we're rare in the development of the disease, but we're not rare in the case of living with the disease, right? It's non-life threatening, which means you may get diagnosed like me when you're 17, and then you may have it your whole life. So I'm going to be here a good while. And so I count in those numbers repeatedly, long-term. So there's more people living with it than diagnosed each year, for example. And so the prevalence of a disease is the measures of all cases or the proportion of the total population. And so people who have TGCT, whether newly diagnosed or been here, like me, 10 years, you're 44 people per 100,000 right now have nodular disease, and 11 people per 100,000 have the diffuse form. So if that starts to get the numbers, we're not rare in existing, at least. We're rare in developing the disease. Nice caveat, right? And so TGCT can arise in the same cell classification regardless of the location. So whether it's the joint between the spine, the joint between the jaw, the joint in your wrists, knees, etc., these cells are all the same. So the disease can arise in those areas. And so approximately 80 to 85% of the disease occur in and around the knee. The rest are with ankle and hip being split for the most common, and around less than 5% occur in other locations like the shoulder, the elbow, the wrist. And so if we look at the nodular form or the localized form, the fingers, the digits, these guys, the toes, that is more common of the disease. And you do see some patients that have a localized form in the knee or the hip, and that is a little less common. You also have the diffuse form, which is most common in the knee, with the ankle second and the hip third. Sometimes they rival for which one's more, with upper extremities being a little less common. So why did this name change, right? I said that we took all of these, we shoved it together into a single entity. One was because it's wildly inconsistent. As you guys probably have all experienced, if you have someone calling it PVNS and someone calling it TGCT, that totally changes what you Google, what you put into Facebook, how you find people. So trying to have a singular name helps patients, but it also helps providers have expectations of how it should be treated. So PVNS is a synovitis, which is an inflammation of the synovium, the inflammation of the joint lining. None of us probably feel like we have an inflammatory disease, right? Steroid injections do not work. One reason we switched the name, right? Synovitis are usually treated by steroids. We're unresponsive to steroids. So you start to see that the biology is reflected in the name. So with that name change, we're trying to change how people talk about the disease. And so it's not just a simple inflammation, it's a neoplastic disease, which is a very fancy word for tumor disease, essentially. And it should be treated with multidisciplinary care at a cancer center. So I know who Sting is, which should be a shock since I didn't know who Jimmy Buffett was 5 seconds ago. But Sting, an Englishman in New York, still remains an Englishman. So whether the disease is in your knee, in your hip, in your ankle, it is the same disease. So what causes TGCT? TGCT typically affects people around 20 to 50 years old. There's a younger preponderance when you have diffuse disease from 20 to 40 years old. And so TGCT occurs sporadically. There's no magic answer that I have for anybody. It is neither inherited nor passed down. That's often was a really scary part when people get diagnosed. Am I going to give this to someone else? No. Nope, you just got unfortunately lucky that you got diagnosed with this disease. There is a prevalence of men and female, which is similar, with a slight female predilection when it comes to the diffuse disease. And so you have, like, as I said, younger for diffuse disease, but you have patients here who are outside of that norm, we'll say. I think some people here were diagnosed in their 70s. So it's not uncommon. TGCT strikes randomly. It is multifaceted, but there is no environmental, geographical, occupational, dietary, lifestyle cause to TGCT that's currently known. And if there was a major risk factor, we would probably know at this point. So it's probably many combination of things involved in this. We have people from South Korea, Mississippi, DC, right? We may have very different ways of interacting with the world, eating, family structures. So if we were to share something, you would probably notice in different cultures too, right? Like Asian cultures eat very differently than Westernized cultures. So you would notice if food or things like that impacted it, you would see higher numbers in those groups. And currently we don't. So we don't know a lot of things, right? What do we actually know? So we know what TGCT is made up of, right? We have microscopes, we have science, we have technology. We can at least tell you what your tumor is. We may not be able to tell you where it comes from. And so TGCT is made up of soft tissue, or mostly soft tissue, which is part of this lineage called I always butcher the name too, is the mesenchymal, you guys know it better than me. Mesenchymal, oh, always butcher it. You can tell I got my PhD during COVID. Not a lot of verbal confirmation here. So I never had to say that word as often but all of these share some lineage, right? If we look at a family structure, you share a lineage with your family. So adipose tissue, which is a fancy word for fat, bone, tendons, marrow, cartilage, muscle, they share the same lineage. They're all connective tissue. And so I like to simplify everything because I find patients are able to talk about it with their doctors if it's in a simplest form. And so if we look at like the family tree of this lineage with maturation of it, you grow up and you become one of these cells. And so if we look at a family structure of the tree, so family tree at the very bottom, that's what you start out as, or it's actually a stem cell. So we can say even more fancy words that won't mean much in this situation. But at the bottom of the tree, it sprouts with maturation into tendons, bone, TGCT, part of TGCT, fat cells, fat tissue, cartilage. And so these all share that component. And so when we dive even deeper into what these cells may include, you have the synovicytes, which are responsible for the production of the fluid component within the cell, as well as absorption of the joint cavity, and blood and the synovial exchange. So when people go, when they pulled out all this fluid in my joint, there was blood, that has to do with this fluid exchange from blood and the synovial fluid from the synovicytes, as well as fibroblasts and stromal cells, which are types of connective tissue, as well as osteoclast-like multinucleated cells. Osteoclast is a fancy term for cells that dissolve bone. So they're bone reabsorption cells. And so when people say, oh, I have damage because of this disease, it's most likely related to osteoclast-like cells that are absorbing parts of that bone. And so if we look up all of these cell types that become part of this disease, it's not one cell that makes up our disease. We say TGCT tumor like it's a single entity. It's made up of many things. It's like a marble. And so it's also made up of immune cells that get recruited to become part of the tumor. And so monocytes and macrophages are a type of white blood cells. So if we pull my family tree example again, you have blood stem cells or white blood cells that mature into different types. And the types within our disease are actually known as monocytes and macrophages, and those get pulled in. Fun fact, our disease is all rusty, right? All of us, when we've had it pulled out, they're like, oh, it's all bloody and rusty. And the reason is because macrophages can be stained with something called hemosiderin. Hemosiderin is an iron storage component. So just like leaving your bike outside in the rain, it rusting, it's almost like through the same similar reaction that the macrophages get rusty. And so that leaves a color behind. So it's actually not the tumor itself, it's these macrophages that are the color. And those are part of that tumor and a part of that system. So that's my crash start. And so if we go basic to like high school, hopefully high school biology, I'm not sure actually if they teach high school biology in the same context, but hopefully. You have genes, which are the constructive blueprint of a cell. And our body is made up of many different types of cells. All of these cells have a purpose, they serve a function. And the human genome encodes a lot of protein. And what dictates that is the code, is the gene involved. And so different cells make different types of protein. And so if you look at the genome as a library, different cells read different books. And so they're going to produce different proteins based off their function. So muscle cells make actin and myosin, which allows contraction. Red blood cells make hemoglobin, which allows oxygen to go through our body. Neurons make ion channels, which allows you to listen and glass over while I talk. right? So all of these are part of a system, and we call this the central dogma. If you've learned anything and you go up to anybody and you go, I know the central dogma, they'll think you're super cool if there's someone like me, because we never get to talk about it. So DNA is made up, it's pulled out, but it's really within our bodies condensed into these tiny forms that look like this. That's chromatin. Each of them is a chromatid. Together, they're chromosomes. Hopefully, you've all heard of a chromosome. That sounds familiar, but maybe not sure what it is. And so chromosomes are that book, and that RNA goes in and reads the book and then tells the protein, or makes the protein, tells the system. So if I take like a blueprint example, I love my examples. So you take a blueprint, the contractor is the RNA, it's sending the message, it's telling the construction workers what to do, and then the protein is created. The construction workers make the protein. And so we have this system of how everything's made, but it starts at the gene point. There's many moments in which, like between these, other things can intervene. So this is a really simplified version, but it's the version you need to know. So what makes up protein? Protein are linear sequences of these fancy building blocks called amino acids. There's 20 of them. I put some of the most common ones. They're probably none of them common to you, so you'll have to take my word for it. The alanine, cysteine, glutamic acid, all of these are make up, and in different formulations, they make up protein. Protein can be really small, like 100, or it can be really big, like thousands of these, but it's all broken down into 20 amino acids. And there's the fancy, so you have the structure, and then they, in different ways, they form and bend. They have their purpose, they have their function. So if you change how one moves, you're gonna change part of its function as well. So everything's so tightly knit. So how do we relate this back to TGCT? So if we look at TGCT, some of the amazing researchers in the world have taken apart TGCT and found that it's aneuploidy, which means it has extra chromosomes, which trisomy means 3. So in the 5 position, which is my circled one, and my 7 position, it has 3. Chromosomes are 2. So we have these extra chromosomes. Why? Number 5, we have no idea. Number 7, we think it may confer a growth advantage to the cells. So there may be more reasons why our disease grows that we don't know yet. But we do know that 5 and 7 exist. So if we look at symptoms that we've all experienced, I love telling patients their symptoms, right? Like we all know our symptoms, but for those in the room that aren't aware, pain is one of the most common symptoms. Around 6 out of 10 patients report pain. Swelling, range of motion limitations, popping, clicking, pinching, warmth, tenderness, etc. But all of these symptoms, what they have in common is they're non-specific. There's many diseases that cause this, many prevalent diseases that cause these, and that can delay diagnosis for 3 to 5 years. So many of us had symptoms way before we had the disease, or before we knew we had the disease, and we probably had the disease longer than that. And so there's differential diagnoses like synovial chondromatosis, synovial sarcoma, sports injuries, femoral acetabulum impingement, labral tears, fibromas. There's so many things we are misdiagnosed for. Gout, I've seen. Gout is really common, weirdly, in the Netherlands to be misdiagnosed for. So there's many diseases that mimic our disease itself. And so I told you guys all about the genes. I told you about protein. So what is wrong? We have an extra chromosome 5. We have an extra chromosome on 7. So we know those things are different. However, what is the major hallmark, this was the key feature found that allowed our disease to be targeted, is that we have something called a translocation of chromosome 1 and chromosome 2 that fuse parts of. A chromosome translocation is a chromosome abnormality in which one chromosome breaks and attaches to a separate chromosome. And so if you see in, do I still have chromosome 1, this section attached to chromosome 2. And so what that caused is for a protein called colony stimulating factor 1 to be created in too much, in abundance. And only 2 to 16% of the cells have this abnormality. So there's other things going on, right? We just don't know what they are at this point. But this translocation was the major discovery in our disease, which allowed it to be targeted. So chromosome, I said it was like made up of amino acids, all proteins are, right? You guys know that now. And so it starts with a methionine, it ends with a lysine. It is 552 amino acids long, right? Is that big? Is that small? It's actually not too big of a protein. And so how this protein works is CSF binds to a receptor. A receptor is a protein that sits inside and outside of the cell. And so when it binds, almost like a baseball into a catcher's mitt, it internalizes a response. So it internalizes a message within the cell. And for us, that message is swelling, pain, growth, etc. So I just told you a whole lot, right? That CSF is part of this pathway that's involved in our disease. It's the major pathway. And so CSF1 is the protein that stimulates that growth because it brings in all of those monocytes and macrophages as part of it. And then our tumors also grow, right? It's like we're putting pieces together. So these cells all become part of the disease. So it signals it to grow. So what is CSF? CSF1 is a family member of a large protein structure called the tyrosine kinase family. Yeah, this is overwhelming to everybody, don't worry. But you can see CSF1, we have KIT, we have ABL, those are the main features. So if we, again, have like a family tree, these guys share structures, they share parts to them, they share parts of functions. So if you think of them as a family, it may be a distant cousin, where if you run into them in public, they may have similarities. And so when we talk about targeting treatments that target TGCT, I will let the doctors do what they doctor best and let them discover and talk about that. But often you'll find that the inception of these drugs started with targeting other parts of that family that I just showed you, and it happened to work in our disease, right? It happened to work, and that started the concept of targeting our specific disease. Once we realized, well, these other drugs target similar proteins, could it work in our disease? And so that's the concept of almost all of the current medical systemic treatments is based off of this targeted approach where they stop that interaction between tumor promoting cells or those monocyte and macrophages with the TGCT cells, and they block that interaction, which stops the growth of the cell, and most of the time causes the cell to shrink as well. So we have many clinical trials. I'd be remiss if I did not mention them, and Dr. Tinoco will go over them in detail. We have off-label drugs in the United States. These off-label is a specific, very regulatory word for that it's not approved for the indication you're using it for. Imatinib is a good example. It's not approved in TGCT, but many of us have seen or used it. Nilotinib is another one. These are also globally available. Approved in the United States, we have pexidartinib. It was approved in 2019. It is the only CSF1 inhibitor specifically made for that, but it fits in that family of tyrosine kinase inhibitors. We have drugs as well in clinical trial. We have the AMB injection, which Dr. Tinoco will cover, as well as imactuzumab, which is currently on pause. The phase 3 trials include vimseltinib, which is currently closed to enrollment. So you cannot currently enroll in any of the trials there, and we are waiting for potential approval at some point. Pimicotinib is also at many sites currently, and they're opening more, including California, Washington at Fred Hutch, Ohio, here possibly at OSU, MD Anderson, as well as other countries. That is the only currently open trial at many of those locations, whereas AMB is still opening its trials as well. So any questions we have? Oof, I am so good on time. We have 5 minutes for questions. And if you did not hear it originally, here's another beautiful scan option for my registry to take part and increase the research of TGCT. That helps with funding, that helps with all of our experiences. Often you see medical journals that talk all about the tumors, but it doesn't really talk about the patients as much. So we would love to talk about the patients and the medicine, but patients as well. So if you have not, this will be everywhere. And I will take any questions quickly. Yeah, Rashida.
Hi. My question for you is when you were talking about the CF1 cells and you mentioned that the translocation occurs in 2 to 16% of the cells.
Yes.
Does the percentage change based on whether you have localized or diffuse?
We don't think so. It doesn't seem like it, at least, right? So CSF1 is not looked at clinically. You don't know how much you have. I don't know how much I have because it doesn't change treatment options. If you have 2%, does that mean you're not going to respond? You may still respond. We have no idea. So it doesn't inform anything. So we don't look individually at each patient. But it seems like there's a spectrum, and it doesn't seem like that spectrum of 2 to 16% is the same as the phenotype or how it presents in patients.
So, so going back to your one of your tree slides, you talk about how the word I can't pronounce either, and it can go into fact, it can go to all the different.
Oh, yes.
So is that part of the reason why it presents so differently in everybody? Because everybody's and how the cells that it disrupts is a little bit different?
Not as much that, but it is why we're in the sarcoma family, right? Is because sarcomas are also within the connective tissue. We share similar lineage. So that's why the same doctors treat us. And so that's why you see we're in these cancer. Everyone goes, it's not cancerous. Why are you at a cancer center? It's because they treat diseases that focus on that lineage.
And so that's why, even though it affects the synovium, I guess just because the PDNS, I just had the synovium.
It's not always in the synovium. No, that's, again, let's get rid of the word. I'm very pro, but you'll see that there's a lot of, I think it's hard for people, it's habitual. And if they don't see it very often, there's not a lot of motivation to change the word. But it changed in 2013, so. If not any other questions, I will also turn it to Dr. Burgess.